welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. Ming and Stephen for joining. For any of you guys in the audience, you may know that Go is building a Bitcoin layer 2 and ZKM is a zero knowledge virtual machine for verifiable computation. But maybe some of you guys are wondering, well, how are these two related? So I'm wondering, Ming and Stephen, if you can discuss about how ZKM is contributing to GOAT, and then also how GOAT is contributing to ZKM.
Yeah, sure. So all of this is part of the verifiable computing scheme. And for that, you need a zkVM. So that's what ZKM is building. We call it ZK MIPS because it's based on the MIPS ISA. And GOAT is a application framework that utilizes this scheme. And also we at ZKM is building and designing a universal, we call it Bridges Bridge, Entangled Rollup. So it's a universal rollup, and GOAT is also connected with ZKM on this endeavor.
Yeah, and GOAT network is a Bitcoin layer 2. So basically, from our from the intuition that it's need to generate a proof for the layer 2 blocks and then verify the blocks on a Bitcoin. Okay, so in this case, we use the ZK MIPS to generate the proof of the GOAT network. And since the ZK MIPS is a ZK virtual machine, that means we can generate a proof for the type 0. We can build the type 0, ZK EVM. And then regarding the proof verification on the Bitcoin, actually we currently there are different solutions like the BitVM2 or CollidVM, or even some other maybe some other solutions in the future. But currently we think that BitVM2 is one of the most practical solution right now, and we need in the BitVM2 protocol, the operator need to generate the proof. It acts as a prover, generates a proof, or or they can leverage the proof network like a ZKM proof network to generate the proof, and then starts the key off the reimbursements. So basically, the ZK proof or the ZKM is the core infrastructure of the GOAT network. Yeah.
Okay, so it sounds like for on the GOAT side, ZK MIPS is helping to generate proofs for GOAT, and on ZKM side, Go is part of the Entangled Rollup network that ZKM is building. I'm very curious to also hear about where these narratives for both GOAT and ZKM converge. So Ming, you mentioned about the end goal for ZKM is one of the end goals is to build out this Entangled Rollup network and to be a universal settlement layer as well. And GOAT's role is a layer 2 within this universal settlement network. So I'm wondering if you two can maybe let our audience know about where these narratives converge and what the end long-term vision is for both GOAT and ZKM.
Right. I think the problem with the whole industry, blockchain/crypto, is that it needs a direction that stick to the original sort of goal or design principle of Bitcoin, which is being a permissionless, censorship-resistant, decentralized system. And in order to do that, it needs to overcome several hurdles. One of them is scalability, because at the base layer, which is blockchain layer, it's very hard to reconcile performance and consensus. So it's you also probably heard of Ethereum's trilemma, so scalability trilemma, To solve that, there are ways, right? Which is you build more layers, right? So with 2 layers, you can, Ethereum's already kind of resolved the trilemma. They kind of solved the trilemma, overcome the trilemma. But if you add another layer, then there's a question of consensus, right? The security. We have many side chains, we have and bridges, and those, unfortunately, they're not very secure, right? They're, like Kevin mentioned, many scammers, pyramid schemes. They're happy to take your crypto and run away with it, and they kind of successful in doing that. All the bridges eventually will kind of fall into this trap, right? So everyone will worry that your bridge will kind of just run away with your money, because that's the things they could do and they will do. So we still need to solve this problem, and the solution is a framework that needs to be as secure, with more layers, as secure as the base layer. And how to do that is the answer is a rollup, right? The rollups are kind of vertical. They're a vertical solution. They don't really do cross chain. They can do like cross rollups, right? In Ethereum, you have many rollups. It's easy to do like cross rollups within that. But is there a way to kind of do cross chain, like cross heterogeneous different blockchains with rollups? Yes, there's a way. So we call it universal rollup and also entangled rollup, because they are building interoperability on a radically different protocol scheme that is actually relying on preconditions instead of message passing. So with that, it can be as secure as the base layer. So that's what we call entangled rollup, bridges to the bridge. So this is a revolutionary, radical, different solution. And so that's our end goal. We're betting on that, because if you don't have the scalability, you won't have the users. Then Bitcoin will always stuck to be just a one application blockchain, not even Satoshi's original P2P payment system, let alone the millions of apps on in Web 2, right? So in order for Web 3 to have that many apps and also be as secure as the original base layer Bitcoin, you need this. You need this framework to be as secure and as versatile, and with all the apps to be able to build anything on this system, not just the payment apps. Okay, so that's our perspective, and that's what we're building.
Yeah, from the Go Network's perspective, I think first we, as we discussed, we need a bit of VM to build the bridge, kind of bridge between the Bitcoin and the Go Network. So, and meanwhile, I think for almost all the layer 2s or ZK rollups, they need some asset from the other blockchains. Like for the Go Network, we still have layer 0 between the some ERC20 or BCB. BC, BT, BM, let me, BNB, Bitcoin from the BNB. I forgot the exact the token name. So I mean we still have multiple bridge between the Go network and the Azure blockchain ecosystem. So basically, this is some of them. Like bit of VM to bridge, it's like trust, it's like permissionless, and we just need one of n, honest assumption. And for some other bridge, like maybe layer 0, maybe we need more than one honest validator or operator there. So, but so for the integral app, actually everything will be like encrypted by zero knowledge proof. So you trust the proof, you trust the mathematic, and you don't need trust the validator, right? So it's more kind of enhanced security for all those existing bridge So I think for when we for the convergence, I think it's a non-term plan because we still need time to for example, if we want to the Metis or the other like Ethereum to bridge the WETH to our core network, maybe we need to build some blocks like the real-time proofs for all the other chain, and then we can use those kind of proof on Go network. So can we can verify that the transaction has happened on the other chains is valid, is a valid proof. So it's still some time I believe to net different blockchain ecosystem to consider the same format or same infrastructure of the ZKP. So yeah, so but since the ZK MIPS is a very general purpose ZK virtual machine, so and I believe the ZK MIPS 1.0 has a very good performance on the road to implement the real-time proving for Ethereum's mainnet block. So basically, it's not far away. Actually, it's not far away, but we still need to, have like a CCIP. I mean, the cross-chain message protocol between all those different, blockchains. So I think that's maybe the next step the Entangled Rollup need to build, and so yeah.
Yeah, so it sounds like from Goat's side, Goat is really heavily building on BitVM2 and inheriting that native security from Bitcoin. And on ZKM's side, ZKM is really using the power of rollups as these interoperability mechanisms to facilitate cross-chain transfers. Okay. And also wanted to hear more. We talked a little bit about the architecture side. Wanted to hear more about some of the use cases that you both see as having most potential to being built on both ZKM and Goat. Are there any that are currently being built out, or any that you hope to see in the future being built out on both ecosystems?
Goat is actually building. It's actually ZKM's Entangled Rollup's first use case. So, Stephen, why don't you? And I'll follow up because you're the first. I mean, like Goat is the first use case of Entangled Rollup. I mean, like started because it's the reason Goat is building on BTCL2 is because it's the hardest. As you heard, there are many trade-offs that you have to make when you develop Bitcoin, because Satoshi himself kind of just hammered away its ability to do apps more than what it can offer right now. So it's really hard. But when you build a application capability for Bitcoin, Bitcoin layer 2, then it opens the door for more apps, and more apps also being connected to other ecosystems in a secure way, because you have to secure BTC. If people lose their BTC over whatever apps interaction with other blockchains, that's kind of unforgivable. So, well, anyway, so.
Sorry, can you repeat the question?
Yes. Are there any specific use cases that are currently being built on Goat, or any that you'd like to see in the future being built?
So regarding the zkVM perspective?
Regarding Goat's perspective.
Okay, yeah. So yes. So first, I think the a major difference is how to generate the proof for Go network and like for the ETH proof. As we know, zkMIPS is generates the proof for Ethereum's mainnet block. So it just generates the stack proof for each block, but for the Go network, actually it's especially for the BitVM2, it's need a group 16 proof. That means, for example, when the operator kick off the reimbursements, they need to generate a proof from the genesis block to current block that's including the bowling transaction, or we say the pick out, at least the pick out transaction, okay, for the original BWM2. So that means we need to have the block proof or shadow proof for each block, and then aggregate all the proof, and then wrap the stack proof to group 16 proof. So basically, this is another, so basically we need to aggregate maybe more than 1,000 block proof, and then we also need to allow the operator to kick off in a very short time, like maybe 10 seconds or half a minute. Okay, so that's another part of the demand from the zkMIPS. So we need to so basically our solution right now, we need to generate the proof for each block in real time, like less than 3 seconds. And then when we generate the block, the proof for each block, we need to aggregate the block proof with previous aggregated proof. So that means when the operator wants to generate the proof for his reimbursements, he just need to generate the block proof and another aggregation proof. So the total time would be can be controlled in less than like 40 seconds. Okay. So and include of course it's including the wrap proof from the stack to the group 16. Okay. So this is some specific demands right now. I think. And we still think 40 minutes is not is still too long. Maybe 10 seconds or 5 seconds. So I'm not sure if we can do that in a short time, but I think we from zkMIPS perspective, it should be done in the near future. Yeah. So for some other perspective, I think we actually currently we are talking about the quantum safe, right? So I think it's not a problem for the zkMIPS, because the zkMIPS can generate the stack proof and which be considered as a quantum safe. But for the for the BWM2, it's just verify the group 16 proof, so which consider is code based and not quantum safe. So that's I think that's also we need to solve this problem maybe in the next maybe it's a problem for the next 5 or 10 years, but definitely it's a problem. So that's also we want to solve with the zkMIPS team, I think. Yeah.
Yeah, yeah. There's still a lot of practical obstacles to make this system as smooth as the kind of scale the app space is needed. 2048-bit of quantum resistant system is definitely needed. That's something the industry talks a lot, but I think the whole industry still needs the users before all the infrastructure can fully flaunt their capability. So for that matter, I think the infrastructure we're building is twofold, right? It's the infrastructure for proof networks for all the basic building parts, and also another I think the industry is lacking is the UX part, right? So I think the Ethereum system is kind of ahead of everybody else in that. For example, they have the kind of abstraction and all that. Entangled Rollup framework want to bridge this difference. So why can't we spread all that goodies from the system that builds the most to other systems that probably have more value, right? Bitcoin definitely have more value. It just needs a lot of user who can actually utilize that value, right? You want your Bitcoin to work for you, right? Not you sell it before you retire or before you die. So in order to do that, we need a lot of UX technologies in addition to the building blocks, right? Like you need a Windows system instead of the just the x86 CPU. You need more than a CPU to build apps. So this is how ZK MIPS is building on this power of the zkVM, which is a universal solution to verifiable computing. Its power is, I think, is undervalued, utilized. I think mostly due to our collective lack of imagination. I still remember Steve Jobs used to say, users don't know what they want, right? So if you just give them like a wallet, they think wallet's the only app that's worth building in all of Web3, right? So right now in Web3, most apps are like wallets. And but look at Web2, right? Yeah, millions more, all kinds of use cases. I know people are building, on like, for example, supply chain, others that they kind of, but all of that, you bring all of the diversity of apps. A lot of time, the infrastructure is not there and they're not secure. And people are worried, right? They could lose their money using the app, right? That worry is always there. In Web2, there's also the chance you get scammed, but less so because they have the centralized companies, right? Like you can always call Google, right? I lost my money, right? Google probably will reimburse you. In the Web3 world, there's no such entities because it's decentralized when you need it the most. It's centralized when they take your money, right? So we're trying to kind of sort of make this more smooth, that you can keep the security, you can keep the fundamental feature that attracted you to the world of Web3, but you also can enjoy the rich applications, utilities, while still kind of being secure with your assets, with your cryptos. So that's the kind of thing we're building. We're building in 2 tiers of infrastructures, and that is the kind of zkVM, the power of zkVM that's less utilized as I mentioned earlier.
Yeah, thank you very much. And thank you, both of you, for mentioning all of these considerations that need to be kept in the future. You mentioned, Stephen, about adjusting to real-time proving when that time comes, quantum resistance, and Ming, you mentioned a lot about how we can really optimize for that user experience. And I think that's a really big part of our discussion today, of all of these sessions, how we can better optimize the end user's experience. So thank you so much to you both for all the insights. Really appreciate you for being here.
Thank you, Alice.
Thank you.